Hello.
Hi Lopa, how are you? I missed you last week. You forgot, huh?
Oh, yeah, Miss Priya, I'm sorry.
No problem. Happened, right? I have forgotten. Yeah. என்னடா சொல்லுமா.
Miss Priya, I was wondering.
Tell me.
Oh, do we have class next week? Cause I like 4th of July weekend. I was wondering if we have class next week.
No, ma. Actually, first week of July is a holiday. Wait, let me see. Vagmi is not here again in class, huh? Yeah, no, after a while. Let me quickly. I don't know how to remind. Some of them are really missing every time. One second, Amma. Vagni, are you in here? Vagni? He's not here. Okay, ma'am. Give me 1 minute. It's okay. I just want to make sure I have all the. Recalculate. Okay. June 23. So let's see. Wednesday. Okay. So Parvini is in here. I know. Siddhi is in here. I know. Dwani is in here. Krish is in here. Shagvi, are you here?
Yeah, I'm
Shagvi, Cheryl?
I'm here.
Anirudh? Anirudh Manav. Anirudh is not in here. Whom did I know?
Yeah.
Yeah. I got you. Okay. Akash, I know he's not in here, but wait, let me remind them. I don't mind reminding them. 1 second. Okay. And then who else did not come? Okay, Akash is the only person and Bhagni. Oh my God. Okay. Okay. How was last week homework, guys? You're able to catch up well, right? All of you?
Yeah, it was easy. Last
Yeah.
week
Yeah. Yeah. Go ahead.
Oh, nothing. I just said I was able to finish.
Easy. See, more, yeah, for many units, it's more of a revision of algebra 2 and understanding functions very well. That's it. All about pre-algebra. And if you do well here, right, your fundamentals will be solid. SAT will be easy. Okay, you don't need to prepare separately for SAT if you understand the concepts. AP Pre-Calc, as I said, right, they've revamped a lot and it is more of a revision of algebra 2 when it comes to polynomials, when it comes to rational functions. Okay, my thought is we will finish rational functions, we will finish polynomials, if possible rational functions before the before school starts. That's the plan. Okay, maybe for another few units as well, it will continue to be a revision of algebra 2, but but every time when we revise, right, you will add more to it. That's the plan. Okay. Krish was the homework easy. Did you have any questions? Shragvi, how about you and Krish?
No, I didn't have any questions. I
Cool.
have 1 page remaining though.
Yeah, but definitely do whenever you have time, make it up, okay?
Yeah.
Because the next week we have holiday. When do we have the holiday? Let's see. I just want to make sure we're all on the same page. Today is 25. 25. Next week we don't have class. So you can please catch up. If possible, I'll give you more work as well. Okay, so that way, I'll see. I'll make sure you have some amount of good work to go over whatever we have covered. I'll finish polynomials, get into rational functions if possible as well. Okay, so that way you can you have time next week and the next week, 2 and 9. Next we are meeting on 16th of July. Got it? Okay, we are clear, right?
Miss Priya?
Lopa, did I answer that question of yours?
Yeah.
Right. Okay. Yes, ma. Tell me.
I had 2 questions on the homework.
Homework, ma. Okay, good. Good to know. Okay, let's see. Yeah, Rosie. Okay, let's see. Let me share the screen. Siddhi, did you do the homework?
No, auntie.
Why, Amma?
I was busy this weekend and I didn't have time to do it.
Ayyo, that really pushes me a little, meaning I'm worried. I am really worried. I don't know what to say, but okay.
It was in the 3rd packet.
Okay, Marcia, what is it? I had questions on some of you. See, I did go over most of yours. Siddhi, okay. Siddhi, Shragvi. Okay, Shragvi, yours is also missing, right?
Yeah, I did
Ashrita, huh?
I did the homework. I just didn't put my pictures.
Did you check with the answer key?
No, not yet.
Ma, that won't help, right, Amma? For
Yeah.
saying definitely you'll have to check with the answer key, right?
Yeah.
Okay, Anirudh Satish is also missing, right? He didn't come. I don't know, guys. Okay. Anirudh is missing. Okay, let's see. Okay, what is the question, ma? Which one? Which one should I take?
The 3rd packet.
You have to tell me CA2, CA1, C names, right? CA2, CA1, packet and solutions.
It's the one under the solutions.
Okay, sure. What is your question?
The last 2 questions, I didn't really understand them. I didn't get them right.
Oh, okay. Okay, no problem. That's good. Good that you asked. Okay. Table gives values of the function g for selected values of x. Okay, so g of x is the function, x is your independent variable, g of x is your dependent variable. Okay, they've given some values. Okay, don't worry about these. They have not given that. Okay, the function is quadratic, they have given. If the function is quadratic, what happens if the function is quadratic? The second difference is the same, we know that. Okay, but there are only 3 values given. Let's see what to do. So here 2 is the difference here. Okay, it's equal length. Okay, minus, so here how do you find the difference? -1, successive value minus 5, which is a 4. Then 0 minus 1, it's a 0 minus 1, it's a +1. Okay, great. Now what do we do? If the function g is quadratic, what is the value of g of 8? Okay, so from here, the second difference is the same, correct? We know the first difference is this. Manav, you finished this, right? How did you do, Manav?
I did good, but I think I was a bit stuck on these two.
Oh, I see. I see. Okay, so for a so they're asking what is g of 8, right? This one is 8, x is 8 or x is 6. What is that they're asking? For every 2 they have moved 0, 2, 4, 6, 8, right? Now, how are we going to do this? We have to make the second difference the same. So let's see. Okay, when you think about it, right? Second difference, first difference we already calculated. Second difference is -3. Do you see it? Second difference is -3. In a quadratic function, the second difference is the same. In a cubic function, the third difference is the same. We know that. In a linear function, the change, the first difference, this is the first difference is always a constant. We studied that last week and we know that as well. Now, for us to calculate g of 8, right, let me draw it here. To 0, 2, 4 we know, minus 5, minus 1, 0 we have. So the first difference I calculated, minus 1 minus 5 is a 4. Then 0 minus 1 is a 1. Now, we need to calculate for 6 and 8 because it
Miss
moves.
Priya,
Yeah, ma?
I thought you calculate the rate of change.
Yeah, ma. This is the rate of change, right, ma? For every 2, we have 4. For every 2, the next 2, we have 1 here, right? This is the rate of change, right?
Wouldn't it be like y2 minus y1 over
y1, correct, ma. y2 minus y1 divided by x2 minus x1. Here, I am calculating the, see, I have to determine the values in here, right?
Mm-hmm.
Huh. If it is a linear function, it's fine. Basically, what is the rate of change? You tell me. Rate of change is delta y by delta x, right? That's what you're saying, right? y2 minus y1 divided by x2 minus x1, correct? So here, if you do y2 minus y1 by x2 minus x1, you can never determine this, right, ma? But you know, in a quadratic function, the second difference is the same. You see what I mean?
Mm.
So look at it, rate of change is decreasing. Do you see 4 becomes 1? So it has to decrease even further. Am I making sense? Am I making sense?
I don't understand how, like, why you got the 4 as the rate of change.
Okay, I should have said first difference. Can I call it first difference?
Yeah.
Is that better?
Yeah.
I correct myself. Okay. So see, rate of change is this divide by 2. This divide by 2, right?
Yeah.
Okay, let's go ahead with the, see, I need to find out these values. If I find the rate of change, I'm not going to get the values, right? For every equal length interval, I have to calculate the first difference. The first difference I calculated already, right? Now I know 4, 1, right? The second difference is this, right? Second difference is a minus 3. However, how will I know this value? I will not know this value at all, right? But 4 minus 3 is a 1. So 1 minus 3 here, it has to be a minus 2. And then the difference between this should be this, right? So this has to be a minus 5. So first we'll go from here. You know the second difference is a constant only from the given values. Okay, meaning you can find the second difference from the given values very easily, right? That is a minus 3. You know the rate of change is decreasing as well. Meaning, what is this? When you look at it, why I am saying rate of change is decreasing is 4 by 2, 1 by 2. Do you see? Is it decreasing?
Yeah.
That's why the denominator is going to be a constant. So I'm calling this as I didn't mean to call that as the rate of change, but the rate of change will decrease if the first difference is decreasing. Am I making sense?
Yeah.
Because it is going to have the common denominator. Now, then again, I filled this in minus 2 and minus 5. I found it now. However, from here, minus 5, what happened here? When I added this, I got this. Similarly, the reverse I'm doing. Minus 1, add, I'll get a 0. 0 minus 2 will become minus 2. Minus 2, minus 5, minus 7. Am I making sense?
Yeah.
Am I making sense, Manav?
Yeah.
Krish and Shragvi, are you getting that?
Yeah.
Yeah.
So now from the second difference, when I'm going back, I have to do the reverse. That is how I find this minus 7. So G of 8 is minus 7. Make sense? Okay,
Yeah.
guys. One thing I want to underline, or I want you to remember, okay? In these assignments, right, it is so important to do these. You see the last piece, you see, whenever these questions come, right, the last piece are very important here, particularly the packet, right? When you think about it, see here, this one, you see test prep, there is a test prep, right? These are the questions that will mirror in your AP exam. on the multiple choice section. Make sense? Am I making sense? See, your AP pre-calc exam is going to contain some multiple choice questions, some free response questions. There are 6 free response questions. Free response questions will clearly understand. Each will carry a lot of points, okay? But we will clearly know, hey, this is the topic. The question is going to mirror this with different numbers. To that level, we will know on those 6 questions, okay? So it's very easy to knock out those 6 questions. Okay, I'll tell you as and when the topic comes, I will tell you, hey, we are going to have a free response question in this section. So it is easy to get a full score on that free response section. But when it comes to the multiple choice, they can pick it out anywhere across any part of AP Pre-Calc, right? So if you can concentrate on these test prep questions, right, it would really help you, okay? Meaning you will be able to at least attempt 50 to 60% of it. And with more practice, we'll be able to do everything. Make sense? So please have a watch over these test prep questions under every subtopic that we are going over. Okay. Now, did we understand number 15?
Yeah.
Okay, now can I go to number 6? Manav, if you have these questions, you should ask Manav, meaning don't go without doing it. Okay, now what is this? P of X.
I think we did this last class.
Yeah, class, right? In class, I feel like I did it.
We did it, but it wasn't the
Yeah,
same
you said
question.
us to come back to class
Yes,
if
yes,
we
yes,
figured
yes,
it out.
yes,
We're
yes.
like,
I remember this question. The function P is given by P. Okay, let's see. I honestly forgot about this. Let's see. G of X plus 1 minus G of X, right? Where G of X is a quadratic function, P of X is equal to 2. Okay, which of the following statements must, oh, did we do the same question, Amma? I don't remember. If P of X equal to 2, but we said we'll come back to a question. I remember that, but
I don't think it's the same question.
yeah, I feel like because P of X equal to 2 is given, right? That I don't think it was in there. I don't know. I don't remember. Okay, let's see. Which of the following statements must be true? P of X equal to 2. Good. Okay. Let's see. So okay. 1 second, guys. Okay. So this is the Y value. Y2 minus Y1. Okay. Okay. Now the rate of change is 2. Okay, that is positive. Rate of change is positive now. Rate of change is positive now. It is we can't say it's concave up. Okay. Oh, that is crossed out. Good. And P is positive and constant. G is increasing. Okay. I don't think this was this question. This question is very clear, I feel. I don't know. Okay, anyway. I'll go back and check the recording once, okay, after the class. I don't feel this was the question we discussed because this question seems very clear. The function P is given by P of X equal to G of X plus 1 minus G of X, right? What does it mean? Think about it. See, this is a function. They say it's a quadratic function. Quadratic function can be like this or can be like this. Now, G of X is a quadratic function. P of X equal to 2. P of X equal to 2 means what? They are taking up 2 points, okay? 2 points in the sense it has to be, the successive x value has to be greater than the previous x value. They're taking some 2 points, or it can be these as well, okay? Anyhow, when you think about it, G of X plus 1, do you see X plus 1? Do you see, guys? Meaning they are taking up X plus 1, meaning they are taking up an X value, any X value. X can be anything. This is X plus 1, meaning they are taking a value that's after X, 1 unit after X. So when you think about it, this difference, right, the Y difference between these two is positive. Okay, so what do you think about the rate of change? What do you think about the rate of change? So this value is 2. Okay, the difference in x is what? X plus 1 minus x. X plus 1 minus x, correct? X and x get cancelled. So the denominator is going to be 1. Delta y by delta x is the rate of change, ROC, right? Now, delta y is what they've already given us 2. So do you see the rate of change is already, first of all, the slope is positive. because it has to be 2. The denominator can't be negative here. Okay, the numerator is already positive. So definitely the positive slope thing is correct. Okay, because P is positive and constant, correct. P here is positive and constant. The difference between two y values is positive and constant. See, just because 2 is positive and is a constant, the denominator is anyway going to be 1. The slope, it has a positive slope. Okay, G has a positive slope. Now, because P is positive and constant, the graph G is concave up. That we can't say. Why? I said we have a graph. I pick out X. I pick out X plus 1. What we know? The difference, let's say the difference of Y value is a 2 between the two. That's all we know. We don't know anything else. Okay. This is the only part of the graph I have. For that only I'm answering. Okay. Because they have given that as 2. That part of the graph I'm answering. So here it doesn't give any information whether it is like this or like this. So I can't say anything about it's concave up or concave down. For that matter, if this is increasing, right, it's most likely concave down. Okay. Anyway, meaning it has to go up and down like this. So that piece is going to be concave down only. It can't be concave up. Because P is positive and constant, G is increasing. What can you say about G of X? See, it is increasing from point X to X plus 1, right? It's a positive 2. So definitely the function is increasing in that interval. Am I making sense? So the only options that are true are 1 and 3. For that matter, if they have given concave down, that seems right for me on 2. Does it make sense? Ashrita, did you do
Why
the
would it,
go
Miss
ahead,
Priya,
go ahead.
why would it be concave down instead of up?
You can't say concave up or down, right? Only this part of the graph they have given, right?
But you said that you'd rather pick
Yeah,
concave
rather
up.
be concave. Why I said that was, see, anyway, when the graph goes up, first of all, I don't know which part of the graph it is, okay? It might have been like this as well. You see what I mean?
Yeah.
If this is this, I can't say concave down. But there is one chance here, if it is like this, right? See, this is a part of the concave down piece. It's a frown, right? Concave up has to be like this, right, Manav?
Yeah.
Yeah, for that matter, Manav, I honestly don't know what is this piece of the graph. It can be this or it can be this. Okay, when it is like this, then it is concave down. But I don't have those points. Only the 2 points I have. These 2 points I have. With this, I can't decide if it is concave up or down. Can I make that comment?
Yeah.
Okay. Shall we move on? Okay, did you guys understand the other question here?
Yeah.
Yeah.
Okay. Oh, it's only linear. I think we did these problems only last class. Okay, now let me move on. Can I move on?
Yeah.
Yeah.
Hey guys, I really need to move on. Okay. Stop. No documents. Yes, I have it. Okay. 10 point. Oh my God. 9:30 apod. Okay. Last week I did discuss with you about the leading term. Okay. Let's see. Okay. So how do you, did I share the screen? Ashrita, did you do the homework?
I was busy. I was planning on doing it today. I'll do
Okay.
it and then submit it.
No, I have my own. Let's see. Let's see. See, I am worried about some of you not doing the homework. Yes, ma'am. Let me share my screen. Akash. Okay, so coming to polynomials, right? We are going to discuss polynomials, then move on to rational functions. Okay, do you recognize this? So here, a polynomial can be written like this. In standard form, this should be the highest power of x. If it is not in standard form, it can be written anyways. So here, when you look at it, right, this is called, what is that called? What is that called?
Leading coefficient.
Yeah, that is called the leading coefficient. We are just revising the last part of last class. Leading coefficient. This is exactly in standard form. What is the degree of the polynomial? What is the degree of the polynomial?
N.
N. Good job. So this is the constant final term where x is to the power of 0. And what else I want to tell you? Okay. What is the leading term here? What is the leading term?
A.
A of what? There is a subscript as well, right?
A of n.
Yep, A of n. Okay, now here n is a positive integer. Here n is a positive integer and A of I, whichever it is, 0, 1, 2, 3, 4, 5, 6, all that is a real number for I ranges from 1 to n. Make sense? Ashrita, are you in the class, Ashrita? No switching. Okay, this is concerning to me as well. Okay, let's move
I'm
on.
in class.
Let's move on. Okay, so how about this? Okay, I really want to know this one. How about this one? I really want to have a question on local or relative extrema. Okay, so let's see. Last week we did discuss this. Let's see how much of it we remember. It's okay if you don't remember, we'll revise. If a polynomial switches from increasing to decreasing, what happens? If a polynomial switches from increasing to decreasing, a polynomial switches from increasing to decreasing. Okay. So we are asking questions about local or relative maxima or minima. Okay. Maxima or minima together is defined as extrema, right? So what happens here? If a polynomial switches from increasing to decreasing, there will be a what type of, see, we are talking about local extrema. So what do you think will happen? If a polynomial switches from increasing to decreasing, there will be a, what do you think? Think about extremas and tell me.
Maximum? I don't.
Good job.
Oh.
Good job. There will be a maximum, correct? There will be a maximum. Let me write that down. Maximum. Okay. There will be a, what is this maximum? What maximum is that? There will be a local or relative maximum. Make sense, guys? What is the other name for global extrema? If you don't remember, you have to let me know. I'll go over it again.
Isn't it
Yeah,
absolute?
absolute maximum or minimum. Okay, if you remember it correctly, right?
Yeah.
This is Yama.
How is it a local or relative maximum?
This
Like
is
in
what.
this case, how is it?
Yeah, in this case, do you see these are the maximums, right?
Yeah.
Now, here, this is also a local maximum. Okay, of all the maximum, whichever is the highest is the absolute or global maximum. Make sense?
Yes.
So, global extrema covers both max and min. Okay, here of the three, this one is the global or the absolute maximum. The rest of it are relative or local maximum. Makes sense? Here there are two minimums or three minimums, I can say, right? This is a local minimum. This is a local minimum. Local can be substituted with relative. Okay, this is also a local minimum. Makes sense? However,
Yeah.
this is the absolute minimum. This is the absolute minimum. Can I move on? Okay, so I really have one more question related to your. Okay. How about this? Suppose, let's say I have a graph like this. You see, I have a graph. This is a polynomial graph. In this scenario, right? I'll say, can I call this as an included endpoint? You have to know the way they talk, right? You have to make sense out of it. This is an included endpoint. Do you think it is right? This is the included endpoint. What do you think about this?
Yeah, it's included because the point is filled in.
Exact. These are the endpoints, right? But since
Yeah.
you said it in right, I'm calling the included endpoint. When you write it, when you write the domain or the range, right, you will include it like this, right? So that included endpoint in this polynomial, here this polynomial also is a restricted domain when you think about it, right? This can also serve as a local minima. Do you see it? This can serve as a local minima. Am I making sense? Local extrema. This included endpoint can serve as a local extrema. Am I making sense? Or a polynomial, let's say it is like this. See? Included endpoint can serve as local extremas as well. Can I move on? Okay. Coming to global or absolute extrema, I've told you, first identify all the local maximas. The greatest of them is the absolute maxima. Identify all the local minimas. The least of it is the absolute or the global minimum. How about this? Can we try doing something here? Let's fill it in. Once we fill it in, we'll clearly understand where we are. How about this? This is a polynomial graph, correct? This is a polynomial graph. Now, absolute minimum of, what is this? Absolute minimum of an x equal to what? Somebody please volunteer.
-6. -6.
-6 when x equal to
Oh wait, sorry.
uh,
Absolute minimum of -2 when x is equal to
good.
-6.
Good. Absolute maximum of
Absolute maximum of 3 when x equals 1.
absolute maximum of, does it have an absolute maximum?
Shouldn't it be infinity?
Yeah, it doesn't have an absolute maximum, right?
Oh yeah.
Because it's infinity. One side is going to infinity, right? So it's not, there is none. There is no absolute maximum, but I do understand there are two relative maximums. Does that make sense?
Yeah.
But what are the relative maximums? Tell me.
At -2.
Relative
Sorry, not -2. 2.
to relative maximum.
Yeah, 2 and 3.
I'm a little lost. Which one?
No, the
Which one?
relative maximums are when y equals 2 and 3.
Y equal to 2 and 3. Yeah, x. I'm confused now. I think the way you're saying is as well is confused. Where are the relative maximums?
-4,
Correct.
2.
-4 and
Uh,
1.
1.
and 1.
Yeah, -4 and 1. Okay, and then relative maxes are x equal to -4 and x equal to 1, correct. Relative mins at x equal to?
I can do it. At -3
Yeah,
and 2.
-3 and 2. Yes. But then what is the value of the relative maximum minimum?
1 and 2.
1 and
2.
correct. Relative maximum value at -4?
2.
2. You need to be careful, that's all. And then
3.
3. Krish, are you with me, Krish?
Yeah.
Okay, you're too quiet. Okay. How about Siddhi, are you with me?
Yes.
Okay. So when we have okay. Last week we did discuss this, guys. Suppose in a graph, right? So in a polynomial graph, we end up, what are these called? What are these called?
The
Zeros.
roots.
Zeros or roots or x-intercepts, zeros or roots or x-intercepts. When you see that, right, what do you think? Meaning, is there between these two, okay, can you relate a local extrema with these 2 points? What can you say when you see 2 zeros, right? Suppose, let's say they give a table. Okay, they give a table of x and y values. Okay, let's say this is 0, 1, 2, 3. This is your x value. This is your g of x value. That's the function value. Now, they're saying 1 and 3 has a 0, right? Now, what happens here? Between these 2 points, what can you expect?
An absolute minimum.
A local maxima or minima, right? It can be local maxima or minima, right? It doesn't have to be the maximum. We don't know the rest of the graph. What you can guarantee, if you see 2 x-intercepts, the graph could have been like this, or it could have been like this. Somewhere it made a U-turn. Make sense? So between 2 x-intercepts, what is guaranteed? A local extrema is guaranteed. We don't know whether it is maximum or minimum, first of all. We don't know whether it is absolute or global extrema or not. So we don't know all that. What can be guaranteed? There is a local extrema between 2 zeros. Make sense?
Yeah.
Shagvi, are you with me?
Yeah.
Okay. Now, let's see this one. How about this? This type we did last week, I feel. Yes, we did. That's where we ended the class, I feel. Let's see this one. Can you oh my God, what is going on? Okay, let f be a polynomial function with values. So let me plot it, okay? If I were you, I would have plotted it, okay? Akash, are you with me, Akash?
Yeah.
Okay, f of 0 is a 5. Okay, f of 4 is a 0. F of 7 is a -1. Okay. Are there any guaranteed extremas? Are there any guaranteed extremas? Please,
Yeah.
it's a discussion. Where?
Between when x equals -2 and 4.
Good job. Why?
Because there's 2 x-intercepts and there has to be a U-turn in the middle.
Yep. So between these two values, they have given it, okay? See, this they have given it. I can't say, I can only say yes, there is a guaranteed between -2 and 4. Between this interval, there is a guaranteed local extrema. I can promise this. However, what I can't do is, it can be a maximum or minimum. We don't know. They have not given all the x-intercepts. They have just said there are x-intercepts at these points and the values at these points they have given. So with this, I can say there is a local extrema between 2 and 4. Cheryl, are you with me?
Yeah.
Okay. Now, let's consider absolute extrema of even degree polynomials. Let me erase all of this. I'm going to, let's talk about even degree polynomials, odd degree even degree polynomials, or odd degree polynomials. See, these are all repeats from algebra 2, but algebra 2 you studied without knowing, you studied to a little bit, but here you refine your knowledge of what you studied. Okay, now what do you think about this? If a polynomial has even degree, right, there is either an absolute maximum or an absolute minimum. What do you think about this? Oh, my writing pad is gone. 1 second, sorry. Yeah, I'm back. So if you have for an even degree polynomial, even degree polynomial is what? Who can draw an even degree polynomial quick? It can be any function. Shout out one function.
X to the power of 2.
Yeah, or x power of 4 or x power of 6. These are even degree polynomial. For an even degree polynomial, there is always an absolute. What do you think? Absolute, do you think absolute maximum is there or minimum is there?
Minimum.
Minimum.
It can be both.
Yeah, why?
Because you can reflect, you can have negative x squared and negative x to the fourth.
Very nice. Absolute maximum or minimum. Here, I did write only positives. It could have also been this one. You see, this is the deal breaker. So, for this one, when I draw the graph, I have to draw it like this. For this one, when I draw the graph, I'll have it like this, right? So, how can I refine this? For an even degree polynomial, I can have negative leading coefficient or positive leading coefficient. In this case, what I can promise? If it is a negative leading coefficient, what will I have? Shragvi, you tell me. Is it absolute maximum or absolute minimum?
Absolute maximum.
Yeah. Absolute maximum I'll have. For a negatively, yeah. For a positive leading coefficient, I'll always have absolute minimum. Does that make sense? Dhwani, is it making sense, Amma?
Yeah.
Okay, good. Now, how about this? What do you think this function has? Please volunteer. Oh my God, you're not even see that. 1 minute. I know, you're not able to see, right? How about this? Oh wow. That also moves. Wait, let me see. Okay, how about this? I'm going to erase this. What do we have? What double extrema do we have?
Even?
Correct, ma. That you can't predict. Hey, Dhwani, that you can't predict. Okay.
Yeah.
Even. Okay, correct. Because degree of the polynomial is 6. Correct. So it's an even. But what I was asking was, does it have an absolute maximum or minimum?
Maximum.
Oh, maximum.
Max.
Good job, guys. Good job.
You're on mute.
Oh, sorry, guys. Okay, how about this? We were discussing this, right? Coming to odd degree polynomials. What do you think about it? Talk to me about absolute maxima minima. Think about it. It's easy that way. If you
It
figure
doesn't have one, right?
yeah, exactly. It does not have one. When you think about it and get it out in class, right? You will ever remember this. It does not have.
Doesn't have absolute maximums or minimums.
Yep. Okay. Now we are good. How about this? Let's see. How about, which one did I want to go through? This one. What do you think about this function? Second one, guys. Cheryl, do you want to say? Can you tell me whether the second function has an absolute extrema? Absolute, yeah,
It
extrema.
doesn't because it's x to the power of 3.
Exactly. So it is an odd, it's an odd degree polynomial, right? The highest degree is 3. So it does not. Now, coming to, have you heard of points of inflection? Have you heard of points of inflection? Krish, have you heard of points of inflection?
No. Well, yeah, kind of.
Kind of, right? That's what I'm saying. So algebra 2, yes, you may, but then you solidify it. You have seen this graph. We know that this is a polynomial. We know that this is a polynomial, even degree polynomial, meaning if it is like, it should have been given like this. It's an even degree polynomial and it is having a negative leading coefficient. Anybody who has a second thought on this? It's an even degree polynomial. It has a negative leading coefficient. Am I making sense with this graph by saying that? So here you should know what are points of inflection. Points of inflection means they are the input values where the rate of change, right, changes from, see this point, changes from, this is increasing, it just like that flips to decreasing. Again, this is an inflection point. It changes from decreasing to increasing. So this occurs. So basically why, where and all this can occur when a graph is going to change from, hey, how about this? What is this part of the graph? It is concave, up or down?
Concave down.
Concave down. Concave down is a frown. Concave up is a cup. Concave up is a cup. Concave down is a frown. Down, frown. Make sense? Don't forget this, guys. Okay, everywhere, meaning as soon as you enter into pre-cal, there'll be a lot of concave up, concave down, which we didn't do in algebra 2. Okay, so you should know just the definition of points of inflection. Now, coming to zeros, intercepts, and linear factors of a polynomial function, let's see. How about this? You're going to fill this in, okay? This is just a review of algebra 2. How about this? You're going to fill this in. If we have a polynomial function p, okay, and if p of a is 0, what does it mean? In a graph, there is a polynomial function. On the x-axis, I mark a point a. So for this graph, at this point, my p of a value is 0. Okay, now a is called a what of p?
A root.
Yes, root or x-intercept or whatever, x-intercept or 0. We have, okay, let me write it out as root. Now we have an x-intercept at point,
A comma 0.
yeah, we have an x-intercept at point A. If A is a real number, A is a real number means A lies on the x-axis means, then dash is a dash of P. What is that? What do you think will fit in? Let me fill in something. Is a linear factor of P, I'll fill in. What should be here? If A is a real number, then what is a linear factor of P?
X minus A.
Good job. Did you all get it? X minus A, because that is a linear factor, because see, x equal to A is the x-intercept, right? So x minus A has to be a linear factor. Any questions here? Any questions here? Okay.
No.
Now, how about this? Okay, let me ask this. See, honestly, I don't know whether you guys know or not. This one, okay? And just let's see. Given this polynomial function h of x equal to x square minus 2x minus 3, what are the intervals on which h of x is greater than or equal to 0? Do you know how to do this? Do you know or you don't know? Otherwise, I'll do. That's why I'm asking. Cheryl, do you know? Ashtuta, do you know?
No.
How
You
about
have
you,
to
Ma?
factor it out and set the
Yeah, I know how to
factors to
do it.
0 to get the
Correct.
intercept and then
Agree, Akash. Very nice. So, first find out the factors. Can you find out the factors or you want me to find out the factors? And see, after you find out the factors, let's see, guys. Okay,
-3 and 1. So the x-intercepts are 3 and
-3
1.
and 1, no? Okay.
3 and 1.
Plus
No, 3 and 1. 3 and 1.
negative 1.
3
Oh,
and 1.
3
The
and 1
factors are
number.
-3 and 1.
Okay, 3 and 1. Okay, 1 and 3. Okay. Now, x square, it's a positive leading coefficient. So, it should be like this or like this. Shragvi, option 1 or option 2?
So the x-intercept is
It's
-1.
it's -1. It's 3 and minus.
-1.
Okay, okay, no problem. I did not verify. 3 and -1 now. Okay. Now, should be like this or like this?
Concave down. Concave up.
Concave up. Okay, yeah, concave up. Why? Because of the positive leading coefficient. Somewhere down. Okay, we don't know. This point may not be correct. Okay. Now, what are they asking? What are the intervals on which h of x is greater than 0? So, what can I say?
You can say -infinity to
Correct.
-1.
This side is greater than 0. See, this is the interval where it is less than 0, below the x-axis, right? So, what are the intervals for which it is greater than 0? Siddhi, are you following Siddhi?
Yes.
So, from -infinity to -3, and then, oh, this is -1.
-1.
Sorry,
And
sorry.
then
3.
3
Sorry.
to plus infinity.
Yeah, intervals means I'll always do it like this, -infinity to -1. There is no meaning. See, you're asked about the intervals. We are not going to use square brackets and all. Okay. And then union 3 comma infinity. Any questions? The notations are all important, guys. Okay. Now, so that you know, how about this? How about x cube minus 2x square minus 8x? X cube minus x cube minus 2x square minus 8x. Can we try to understand? For this function, can you find out the x-intercepts? Can you find out the x-intercepts and send in chat? Can you find out the x-intercepts and send in chat?
This chat's disabled.
Dilemma, you have to go to that blue box in the top left corner of the chat window. Did you get it?
Yeah.
Okay. Yeah, I want to show you something a little more for this. Let's see. Oh, good. Okay, you're all good with all this. -204 -2. Hey, Dhwani, there is one more, right, Dhwani? Siddhi, correct.
Oh,
Shravani.
wait, sorry.
Ashita also missed one more. You're missing one. Lopa. Lopa also missed one more. Yes, Dhwani, that is correct. Lopa, did you miss one? Parvini, correct. Lopa, you put it in? Yes. Okay, guys, don't miss one more. Okay, this is a 3. When you see the leading power of x's, 3. So it should have 3 zeros. Does that make sense? Okay. Now I wanted to show you, I want to split it into intervals and show you. Meaning if you understand every part, right, come what may, however the complicated question is, you'll be able to tackle it. So now, for this function, let's consider any function you can consider. So this one, please help me with it. What was it? X square minus 3x plus 1x minus 3, right? So x minus 3 and then plus 1 x minus 3. So x equal to minus 1 and 3, correct? So minus 1 and 3 is what we did. Now when you think about it, the function is like this, then when you can also write out a table. What table will you write out? So you can split it by intervals, right? Minus infinity, you can't put it as minus infinity, but minus infinity to 3. This is minus 1, I'm sorry. So till minus 1, you can choose one point. Okay, so I can choose minus 2. Okay, then minus 1 I'll put a 0. This is x and this is h of x, right? If I substitute minus 2, right, it's going to be negative, it's going to be a positive value. This is how I'll write, okay? Then minus 1, and then between minus 1 and 3, I'll have to choose a value. So I will put 0 and a 2. When I put 0 and a 2, I know that the value is negative, negative. And then beyond, what is this? This is a 3, right? I'll put a 3, 0. And then for a 4, the value is going to be positive. Now, from this, you can clearly say that this interval are the only intervals where h of x is going to be greater than or equal to 0. Any questions here? Any questions here? Guy, Algebra 2 kids which are going to write the CBE, this is very useful. Okay. Do you understand how to find out which are the negative intervals, positive intervals and stuff? Can I move on? Lopa. Where are we, Lopa?
Yeah.
Okay. Manav, you're here?
Yeah.
Okay. Okay, now let's go. Okay. Do you remember about this multiplicity? What is the multiplicity? If suppose a linear factor x minus a is repeated n times, right? Let's consider this polynomial. How are we going to graph this? Any inputs? Dhwani, you tell me, ma. See.
So, like, since -1 is squared, you're gonna go back. Like, it's gonna be
Exactly. So
with the cube. It's like I don't like. It's just the cubed graph, that like one line that you have that bends, and when it's one, it just goes over and then comes back.
correct. Good job. But then what is the end behavior of this graph?
Oh, this is
A
an even graph, so it's like it's
6.
up and up, and then it's
Two,
positive.
2, 3, 6. It is a power 6 graph, right? Yeah.
There's
So
only 3 intercepts, right?
no, right? Meaning, so what do you think? What do you
There are
think?
3
Yeah,
intercepts. Like,
there is 3.
the multiplicity is
Yeah, that's okay. Now let's consider that. Okay. So here, when you think about it, x equal to minus 1 has a multiplicity. This is quite important, guys. Multiplicity of 2. Okay. X equal to 3 has a multiplicity of what?
3.
3. X equal to minus 4 has a multiplicity of
1.
1. There is no multiplicity. Okay, that's fine. So here x equal to minus 2 is a multiplicity of 2 means the graph's end behavior is like this. How did I determine that? Because the highest power of x is what? 2 plus 3 plus 1. Highest power of x is 6. It's an even function. Okay, even function. Moreover, the leading coefficient, when you think about it, right, it's positive. This will have an x square, this will have an x cube, all positive. This will have an x. So when you multiply all of them, it becomes x power of 6, correct? So since it has x power of 6, the end behavior is like this. Leading coefficient is positive. Now this is the end behavior. So from there, the graph comes here at minus 1. You have to know whether it crosses the x-axis or bounces back. We don't know. How do you determine that? When the multiplicity is even, it will always like to bounce back. When the multiplicity, this is all covered in algebra 2, I'm just reviewing. When the multiplicity is
Miss Priya,
even, yeah, ma?
shouldn't the graph start with -4?
-4, Amma. Why?
Because it's x plus
It's
4.
the first intercept.
Oh, sorry. Yes.
And when you say multiplicity, do you mean the exponent?
Yeah, correct. The exponent.
Okay.
Correct, ma. Good catch, Dhoni. She
But
says the -4 is the first intercept, right? So here it's
if it's 1, it just goes through, right?
if it is one, wait, -4, and then it's a -1 and a 3 we have, right? All these are 0 values, right? Okay, now from here it comes. What happens at -4? It has a multiplicity of 1. Multiplicity of 1 means if it comes from up, it goes across the x-axis. Multiplicity of 1 indicates that it crosses. Even multiplicity indicates it bounces where it came from. Makes sense? It will make a U-turn. If it has a even multiplicity, if it has odd multiplicity, then it tries to, okay, let's see this one. So here, and then what happened at -1? What do you think would happen to this graph? It goes here, but should it go across or should it bounce back?
Bounce back.
Bounce back because of even multiplicity. Now coming to a 3, what happens?
Go through.
Crosses.
Makes sense? So yeah, you see the graph is like this. Perfect for x power of 6 graph. So multiplicity works like this. So what is that? That's it. That's it on multiplicity. Krish, are you with me?
Yeah.
Okay. Now, okay, so multiplicity you all understood. This will be a good one to see how the graph looks like. X minus 2, x minus 5 power 4. X minus 2, x minus 5 power 4. How will you graph this function? Quick, if you could show me, it would be great. X plus 7. X plus 7. Can we do this? X minus 2, x minus 5 power 4. Can we do this, please? The graph. See, I would like you to put up a table here, meaning I understand you'll all be able to draw and then tell me where the graph is less than or equal to 0. Let me ask. Okay, write the interval P of x is less than or equal to 0, first one, and show the graph. Okay, now I also want a table like this, meaning what is the leftmost here? What is the degree of the polynomial? What is the degree of the polynomial, Lopa? Lopa?
4.
Illema, see here, what happened to these?
Oh, 1. Sorry.
Don't forget. No. What is the degree of the polynomial? See, this is x, this is x power of 4, this is x power of 1, right? Now, these all will get multiplied. When it gets multiplied, this becomes x power of 5, and then again, if it gets multiplied with x, it becomes x power of
5.
Illema, x power of 4x. So you have to add the exponents.
Oh, so it'd be 6?
Yeah, it is an x power of 6 and the leading coefficient is positive. See, this is positive, this is positive, this is positive. Only when you multiply all of them, that becomes your leading coefficient. So the degree of the polynomial is
6.
now, then what are the intercepts? 2, 5 and -7. So what I'll do, I will have a point -8. -7 is a 0, I know. Then I'll have something in between -7 and 2, right? 0, 2, and then 2 to 5, I need to have 3, 5. So I will put 2, 5, and -7. Now, positive, negative, I need to find out. Do you want to draw the graph and show me, or do you want me to draw the graph? Siddhi, tell me. Siddhi, Lopa, tell me.
I don't have the feature to edit it, so can you draw?
Yeah, sure. So minus 8, if x equal to minus 8, what would be p of x, right? So if x equal to minus 8, what will happen to the graph? Will it be positive or negative? First, end behavior. What will be the end behavior? End behavior is this, right? If you don't understand how I am drawing those arrows, you will have to point out to me now.
For the other points, you just have to plug it in.
Yeah, plugging it in is the easiest way. But is there any other way? Minus 8.
Miss Priya,
Yeah.
I have a quick question. So how do you know that like both sides is gonna go up?
That's what I'm saying. If you don't know, ask now. If it is an even degree function, x square, x power of 4, x power of 6, all goes like this.
Miss Priya,
So the end behavior is always go up, go up.
Miss Priya, can I go get water?
Yeah, please go ahead, ma. Suppose if it is minus x square, it's just the reflection. So go down, go down. Make sense?
Yeah.
If it is x cubic function, how will it go? Like this. Because the graph is going to be like this. Make sense? Did you get how to draw the arrows?
Yeah.
Anybody else who did not understand, please ask now. It's okay even if we have discussed this in algebra 2. It is important that you know right now because this will come. This will come everywhere. So here, I am sorry, minus 8 I should not have drawn like this. So what are the zeros? Minus 7 is a 0. Then 2 is a 0. Then 5 is a 0, right? Now what do I do? How to draw this? So this comes like this. So minus 8 will be positive, right? Okay, minus 7 is a 0. Should I bounce back or what? Ashrita, you tell me. At minus 7, should I bounce back or cross?
Bounce back.
Why?
I'm not sure.
Okay, who can tell me?
And which one do we? Which one?
Minus 1. We are at minus 7, Emma.
Minus 7.
This is
You go crossover.
crossover. Why? Because it has a multiplicity of 1. Now I am in the negative piece. So between minus 7 to 2, whatever it is, it was negative. At 2, what happens? At 2, who can say? Who can say about 2? Shragvi, do you want to say we cross over or bounce back?
I'm not sure.
Okay, no problem if you're not sure, Ma. See the multiplicity. At 2, it is a 1, right?
Yeah.
1, if the multiplicity is 1, it crosses, meaning I'm here, right? I'm here on the negative. So it has to go to positive. Okay, whereas x minus 5, at 5, you see what happens. The multiplicity is an even multiplicity. Even multiplicity means it is positive, right? However, it comes to the 0. But then it has to make a U-turn. Whenever it has even multiplicity, wherever it is, if it is coming like this, it will bounce back here. Positive is coming like this, it will bounce back up. Do you get it?
Yeah.
Akash, Mano, did you get it?
Yeah.
Okay, so for 3 it is a positive, 3 it is positive. Okay, then 5 to infinity as well I need to consider, so that will be positive. Now what are they asking? P of x is less than or equal to 0 is only between this interval. What is that interval? Minus 7 to 2, minus 7 comma 2 is that interval where p of x is less than or equal to 0. Guys, you should be able to draw polynomial functions very well. If you did not understand, let's do one more. Krish, did you understand?
Yeah.
Okay, I just want to verify my graph. What did I do? Yeah, we drew the correct graph. So the graph should be like this. So it came from here, 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 here,
Hey,
here.
Miss Priya,
Yeah.
on the CB, will we have to plot y values of the polynomial?
If we are asked to plot the y value, substitute in here and find it. That's it. And you have your calculator, make use of the calculator. I am telling tricks, those are, I don't know. Calculator, you carry the calculator with you. So make use of it in the CB exam. Make sense?
Yeah.
Yeah, but not in class. When you're doing it at home for practice, please don't use. Please substitute and find out with your brain. Okay, in the exam, you'll be time crunched. Krish, you're okay?
Yeah.
Okay, can we move on? Okay, let's go ahead. Let's go ahead. What did I do? Okay, so, okay, now let's go ahead and find out complex zeros. Complex zeros, successive difference, odd and even polynomials. Okay, let's see this one. Okay, do you all know how to find out even and odd functions? Do you all know how to find out even and odd functions? Okay, let's see. Meaning, before I go to even and odd function, let's finish this because I can give you proper homework on this. Okay, coming to complex zeros, right? A polynomial of degree n has exactly n complex zeros. When counting even with multiplicities, there will be only n complex zeros. Let's say, let's go back to our polynomial function. What was the polynomial function? A power a n x power of n plus a n minus 1 x power of n minus 1 plus a n minus 2 x power of n minus 2 plus a n minus 3 x power of n minus 3 and so on to a power of 0. A subscript 0 x power of 0. Okay, so this is a polynomial function p of x. Here, what I am meaning to say is this polynomial has a degree n. Why it has a degree n? The highest power of n x is n. So it has a degree of n. Then it has how many zeros? How many x-intercepts are there? It has n complex zeros, even with multiplicities. Meaning this is several multiplicities, right? 2, 3, 1. So the degree of the polynomial is what? 2 plus 3 plus 1, right? So this has a degree of n. Even counting the multiplicities, it has n zeros or n intercepts, n complex zeros. Why? What are complex zeros? It constitutes both real and non-real zeros. Real zeros means crosses x-axis. Non-real zeros do not cross x-axis. These are imaginary. Make sense? Imaginary roots. We have studied this in algebra 1, algebra 2. So 2 plus 3j is an imaginary root. If you have this imaginary root, 2 minus 3j should also be an imaginary root. These two are called conjugates. Okay, complex non-real roots of any polynomial always exist in pairs. If there is an imaginary root, its conjugate is also a root. A plus bj is a 0. That means, let's say we have a function. Here, do you see this curve, right? This is an even polynomial because it goes up, it goes up. Here, it doesn't cross the x-axis at all. That means it has two non-real zeros. Does it make sense? Non-real means imaginary, meaning it is making a U-turn not on the x-axis. If it is on the x-axis, then it is a real zero. You have a nice x value equal to 1.1, x value equal to 1, x value equal to 4. These are real zeros. It touches the x-axis. However, this does not touch the x-axis at all, but this point, right, it's a complex zero. Complex zero means, so it can be like this. If this is a 0, then this is also a 0 of the polynomial function. See, here it is an even polynomial. Say it's of the format x square. If it is of the format x square, literally here both are non-real zeros, with this one and this one as the zeros of the function. Siddhi, are you following?
Yes.
So imaginary roots exist in conjugate pair. Imaginary roots always exist in pairs. Meaning this one alone cannot be the zero complex non-real zero of this polynomial function. If this is a 0, this should also be a 0. So it can be 2 or it can be 4, or it can be 6. It always exists in even pairs, non-real zeros. Does that make sense? Akash, am I making sense?
Yeah.
Okay, now, so whenever there are non-real zeros, you have to have them as pairs. There's no way they can exist by themselves. Let's see this one. Let's see this graph. You find out, you will understand clearly. How about this? Can we fill it in? How many real zeros are there? I mean, how many zeros are there for that graph, this graph?
2,
2. How many real zeros?
2,
2,
Non-real?
0,
0,
0,
because this itself 2, 2. That's all, 0. Okay, now here, how many?
1.
Huh?
1,
I mean,
Aha.
how many zeros or how many real
How
zeros?
many zeros?
2,
2. How many real zeros?
1.
1,
Why? Why 1? What makes you say 1?
Because it only touches the x-axis.
Because the only
X-axis
real
once.
one we can see is 1. Like, only one of them we can see.
Ah, okay. How about this? X square plus 2x plus x square plus 2x. 1 second. How about x square? Y equal to x square. What happens here? What happens? How many zeros are there?
2.
2. What are the zeros? X equal to 0, x equal to 0, right?
Yeah.
X equal to 0, I would say, is a repeated root, right? So how many real zeros are there then here?
2.
I know it only shows 1, but it is a repeated root. Yeah, 2, 0. Make sense?
But how do you know it's not imaginary, like one of them?
Amma, that's what. See here, this one is what?
It's all imaginary.
Ah, it has to exist in conjugate pairs. You cannot write 1 here. It has to.
Okay.
Do you get it?
Yeah.
It has to be 2, 4, 6. Okay. When the total is tallied, this has to become a 0. Make sense? See, these are very raw ways of understanding and doing it. You see, meaning bluntly, I'm saying, hey, this is tallying. Go there and put a 0. That's what it is actually. How about this? What do you think about this? Number of real zeros. What happens here? What happens? What type of a function is this, first of all? Oh, it's written here. Sorry, guys. Cubic. Why cubic?
Is there 3 zeros?
Yeah.
Because it goes on to infinity.
Yeah. End behavior is what I would say to see. Okay, good. Number of real zeros is?
3,
Number of real zeros is 3. Non-real zeros is?
0,
Yeah. Here. Again, this is also a cubic function. So it has to have 3 zeros. But I have how many real zeros?
3.
1,
1. 1, right? 1 only crosses the x-axis and it crosses over. You see, when the multiplicity is odd, it crosses over. Whereas non-real 0, see, it takes a U-turn. That is the non-real 0 that doesn't touch the x-axis, right? It is imaginary root. So how many non-real roots?
2,
2.
Wait, Miss Priya?
Yeah.
Oh, wait, never mind. I got it. Never mind.
Okay. Yeah. If you didn't get it, ask, I'm saying. How about the next one?
3 real.
Good. Makes sense?
Mhm.
Because of this 2, because it takes a U-turn, multiplicity at this point would have been a 2, meaning 1, 2, 3, right? So the equation when I write x minus 3 square, and then let's say this is a minus 1, x plus 1. This is the equation for the polynomial itself. Make sense? This is how you write the equation of the polynomial. How? Did you see here? What did I do? I know this is cubic. Okay, so let me say it as p of x. See, this is x, my x, I'm sorry, x equal to minus 1 means x plus 1, right? And then here what? X equal to 3. So x minus 3 I can write. But did you see it is taking a U-turn? So it has to have a multiplicity of 2. How to check it? Literally, when you draw the graph for this one, it will go like this. It will go like this. Okay, how to check this one? See the multiplicity, x power of 1, x square. So, overall, it's a cubic function, right? It's a cubic function, correct? And do you see there is 1 0 with multiplicity 2, because it takes a U-turn. 1 crosses over. Here the multiplicity should be odd. Any questions? Okay, now I think we can, let's see guys. I really want to finish up with this, okay? Okay, now conjugate roots, I already told you. The last one, okay? Okay, if I give this, right, what is the degree of the polynomial? Can you quickly check and tell me? What is the degree of this polynomial? It's a polynomial function. Input is given, output is given. How will you find the degree of the polynomial? Who can explain? You know already. That's what we started with and ending the class with the same thing.
Is it 2?
How do you know?
Because I think it's like a x to the power of 2, like a quadratic.
Miss Priya.
That tells it all, no? It was so easy. Let's see. Yeah, ma, tell me.
The second difference is the same.
Yeah, good. Second difference is the same. How about this guy? Second difference is the same. But Krish, I really like the cleverness with which you answered. Correct. As soon as you see that itself, it's clear, right? Yeah, I should not have given such an easy one. But Parvini, that's right. Second difference. What will you do if the table is given like this? You'll go ahead and find the first difference. 1 minus 0, 3. Then this one is 5. This one is 16 minus 9 is 10. No, 7. Now 2, 2, 2. Do you see the second difference is the same? So it is a quadratic function. Okay, the last one, this is the last problem for the day. We are done with polynomials with this. I think so. Are we done? I don't know. Oh my God, even in odd polynomials I didn't cover. Guys, do you all remember even in odd polynomials, f of x, how to algebraically and graphically prove even in odd polynomials? Do you remember or no? Do you remember how to find out even in odd polynomials? Yes?
Yes.
Yes.
Meaning, if you're given like this, right, f of x equal to, from the graph, you know easily, from the graph, okay, I'll come back to this question, that you can work it out, say it and go. Suppose if you're given the function like this, right, if f of x is equal to f of minus x means, then what it is? What type of polynomial it is? Even or odd?
Odd?
Hey, this is from algebra 2, right? Dhwani, do you remember?
That one's even, right?
That's what I thought. See, f of x, when instead of x, you substitute minus x, but still they both are equal means it's even. F of you substitute instead of x, you substitute minus x and you get the negative of whatever you have, then it is odd.
Because like if the x is negative, that's a horizontal thing, so it doesn't directly make the graph negative.
Yep. So given this, you know what I'll do? They have given this, right? You know, algebraically, this is the best way. I'll substitute f of wherever there is x, I'll substitute a minus x. Please don't skip, okay? Instead of x, I'll substitute a minus x cube plus 5 times minus x. What happens here? Minus 2. This one ends up because of the, what is this? Odd power. This will be minus, actually this will be minus x cubed. So when you multiply these two, it becomes plus 2x cubed minus 5x. Minus 5x. When you look at this, right, it's exactly opposite of this. Do you see? I can write this out as minus of, see, this one is plus, right? So I can write this out like this. This is my f of x, right? Whatever is written here is my f of x. So f of minus x is equal to the negative of f of x means this is an odd function. Are we clear, guys? Odd functions are symmetric about what? Odd functions are symmetric about the, in a graph, odd functions are symmetric about the
Origin.
origin. Even functions are symmetric about the
Axis.
X-axis. X-axis.
x-axis. Y-axis. Do you get it? See, any even functions are symmetric. See, this one. Let's say if I have a function like this, and if I say it's an even function, try to find out the symmetry like this, because it's symmetric about the y-axis. Am I making sense?
Yeah, I just mixed it up.
No problem at all, as long as you recollect and have it in your brain. So this is the algebraical way. Graphical way is, if it is symmetric about the y-axis, it is an even function. If it is symmetric about the origin, it's an odd function. Any questions? Any questions?
No.
Okay. Now the last question is, what is that function? Can you finish that and go? What is that function? Quick, meaning just do only till here. You will understand what is that function. Send me and go. If you send it, you can correctly, you can leave. Sorry guys, pre-cal classes always go above. Yes, ma, Dhwani, you can leave.
I sent
Dhwani, I
my
hope you got, yeah, ma. Yes, Krish, I hope you got how to find out odd and even functions with a graph and with algebraical method.
Yeah.
Okay, because that will be there. So I've covered a couple of topics today, meaning 2 subtopics. That's why it took time.
Bye, Miss Priya. Have a nice
Bye,
day.
Miss
Yeah, ma.
Priya.
Bye, ma. Bye, guys. I'm waiting for everybody to send. What type of function is this? It's a good one. Done. 16 Wow.
Miss Priya.
Yeah, ma. Oh, yeah, you've given me. Sorry. Yes. Siddhi, what type of a function na? Is it linear? It is like that I'm asking Siddhi.
Miss Priya, is my answer correct?
I'm checking. Cheryl, did you understand how, Cheryl? Yes, ma.
Yeah.
Ashita, Cheryl, correct. Manav, not really Manav. Why?
Huh?
Why?
Oh yeah,
Why did you say?
I think I made a mistake. Let me
Yeah, check. Yes, ma, Shragvi. Have a nice break, guys. We are going to meet only after 2 weeks, right?
Miss Priya, am I correct?
Yes, ma. I told you it was.
Oh, okay. Thank you.
Yes. The third difference is the same, right?
Mhm.
Akash, did you get it?
Oh,
Help, huh?
yeah.
Okay. See here, guys. 49 minus 50 is a -1. 38 minus 49 is what? You have
Minus 11, then minus 33.
minus 33. Thank you. How about this? Minus 11 minus minus 1 is?
Minus 10.
Uh-huh. What is this?
Minus 22. 122.
Minus 22. How about this? Then we need one more, right?
Minus 67.
Minus 67, correct. Minus 67 minus 33 is what? Minus 67 plus 33, 4, 3, minus 34, right?
Yeah.
And then what?
Oh, they have common, so 12, so it's cubic.
12, 12, huh?
Minus 12.
Minus 12 minus 12. Did you get it, guys?
Yeah, I got
So
it.
it's cubic?
Cubic, yes.
Okay.
See, since this class was important for both of you only, I called 100% you have to attend. It was useful, right?
Yeah.
Yeah, because it tells a lot about algebra to polynomial functions. Okay, you should be able to look through the table, order, even function, all that, end behavior, domain, range, everything you should be able to say from here. Okay, guys, can I stop recording?
Yeah.
Okay, good.
Yeah.
Okay, bye. Let me know if whatever help you need. I'm going to be on vacation from next week.
Mhm.
Okay,
Bye.
bye, guys.